Looking at this question is, I'm going to solve for theta, since theta is the only unknown in the question, and theta is between 0 and 2 pi. So the first thing I'm going to do is I'm going to solve tan squared theta minus 5 tan theta plus 4 is equal to 0. So press pause. Let's see how you do. All right. So we can solve this a variety of ways. But we could use, now this is called a quadratic trig pattern, because this really follows a quadratic function. So you can say let x is equal to tan theta, right? And I'm just having fun here right now. This is not part of the question, but for sure we've done this trick before, and you can say x squared minus 5x plus 4 is equal to 0, and then you can quickly factor this just like you've done all your life, and you can say x is equal to 1 or x is equal to 4. And then you can conclude that tan theta, since tan theta is x, tan is equal to 1 or 4. And you can, that is a totally acceptable way, and then you could solve for the trig ratio. But for some reason, I like to punish you guys. So I'm going to take a look at it maybe in a little bit different way. So what am I going to do? I'm just simply going to factor it. I notice that my coefficient in front of tan squared is 1. So I'm going to use the product sum property. So tan theta times tan theta times tan theta, and I know that each term or each bracket is going to have a binomial, and we have to identify what two numbers multiply to positive 4 but add to negative 5, and that would be negative 4 and 1. So from this I can say tan theta is equal, or use my zero product property, tan theta minus 4 is equal to 0, or tan theta minus 1 is equal to 0. From this we can get tan theta is equal to 4, and tan theta is equal to 1, right? In this first expression, we could add 4 to both sides. In the second equation, I could add 1 to both sides. I'm going to suggest that we could also use the quadratic formula. Remember the quadratic formula? And here, my variable is tan theta that I would be solving for initially, and that's negative b plus or minus the square root of b squared minus 4ac all over 2a. And I think it's important that you keep that in your back pocket. So for instance, if this was 5, you could no longer factor that. So you would have to jump to the quadratic formula. Anyways, I'm not going to live past lives, grade 11. Let's get back to the question. I broke it down into two trigonometric ratios. Where is tan theta equal to 4? Where is tan theta is equal to 1? So I'm quite excited for this. Tan theta is equal to 1. That gets me really excited simply because I recognize that is an exact value of special angle. Tan theta is equal to 1 in radians from 0 to 2 pi. Oh, that's pi over 4 and 5 pi over 4. This part is straightforward. It's easy. Got it. Now tan theta is equal to 4 might be a little bit different. So now I have to say, well, I'm going to solve it using the unit circle thought process. So tan theta is equal to 4. That occurs in quadrant number 1 and quadrant number 3. Tan's positive in those two quadrants. And then I'm simply going to say tan theta is equal to 4. So I'm going to apply the inverse tan to both sides. And what I get is I get theta 1 is equal to 1.326. Now, if I know my theta 1, how do I get my theta 3 solution? Well, that would be just to simply add pi. because we are exactly pi away in quadrant 3 solution. And my quadrant 3 solution is going to be, works out to be 4.467. Now, you may realize that I stated this and I rounded it. Since I'm rounding to 3 decimal places, I have the luxury of rounding. So when I'm finding my theta 3, though, I would actually keep all of my decimal points and add it to pi, just in case there's a rounding error. You always want to round when you state your final results. So I can say, for a summary, therefore, and I'm going to put a box around this because this is turning into a mess. Therefore, theta is equal to pi over 4, 1.326, 5 pi over 4, and 4.467. So those are my solutions. I have a little therefore, and I'm going to put around a box to make sure it's obvious that that's my solution. Hope this brought some thought to this process. Let's continue on with other examples.